Now I'm going to solve another problem. Write a program to sort an array of zeros, ones, and twos in ascending order. So let's draw an example. 1, 0, 2, 0, 1, 0. So we want to sort it. It will become 0, 0, 0, 1, 1, 2. So let's take a look. So we have moved all the zeros to the very left and all the twos to the very right, and the ones are just in the middle. So it's like there are some lines here. So the first part is just 0, and the second part are just ones, and the third part is just twos. So in a for loop, we can just, so I'm going to erase this part. So when we look at the first element, it is 1, so we're going to put it, we do nothing because we cannot put it to the left or right. So just keep it as is. And next, it is a 0, so we should put 0 to 1's left. So how can we do that? We just swap these two values. So now this becomes 0 and this becomes 1. And next we saw the 2, and we're going to move it to the very end. So the very end is here, so we should swap this 2. So now this one becomes 0 and this one becomes 2. And it is a 0, so we still need to take it to the left. So now we have a boundary here. So we need to move the boundary here in order to insert another element. So we can swap this 0 with this one. And then our boundary will be here. So this becomes 0, this becomes 1, and our old boundary moved here. And next we next we see a 0, and we should put it into this part. So we can just swap this 2 and then take our boundary to the next. So that means if it is a 0, then we swap with old boundary. Old boundary is next number, and update boundary to next line. Okay, now we have done that. So this is 0 and 1. And next element is 1, so we just keep moving. And so that means we can write it here. If is 1, keep moving. So next we see a 2. It is already the end, so we can compare it with itself. So if is a 2, we swap with right boundary. So this is the right boundary now. So okay, since the boundaries are not at any index, we should find some indices to represent the boundary. So we can have two boundaries. So we have two boundaries, so we need two indices. So we can have a left and a right. And the left represents the start of the array, and the right represents the end of the array. And there is also an I, which is the index 0, 1, 2, 3, 4, 5. This I. Okay, so when we see a 0, we swap with the left. So we swap with the old boundary. So that means num's low. We swap it by with itself. Then we keep the I moving to the next. If it's a 1, then keep moving. So I plus plus. And if it's a 2, then we should swap it with the J, with this nums J. Oh, not J, right. So nums R. And now this becomes 0 and 2. So we still need to check the new element before we move I to the next item. So we want to go to the front of this loop, of this for loop or while loop again. So that means if we use a while loop, we should not increment I. Right. Do not increment I. Okay, that's pretty important. And then we see a 2 and okay, so no. So we do not increment I, so we go back to the beginning to check. If it is a 0, then swap with the nums left. So left is here right now. So we forgot to move the left. So update the boundary, right? So L need to increment by 1. So L is here for now. So 0 is less than 1. So we should swap it with the current L element. So this becomes 0 and this becomes 1. And now we can increment the I, and since we already do it here, we have to increment I, right? Yeah, this one also has one because it's keep moving. So next we saw 2. So we swap it with the R right now. And it's just another 2. So it's nothing here. But we need to decrement the R by 1. So R should be here right now. So we should write it here. And R minus 1. Okay. And now we see another I, so we just keep moving. So I is here right now, and it is a 2. So by our existing laws, we should swap it with we should swap it with oh sorry, I haven't done this one yet. So we saw the 2 and we put it here because our R has already decreased when we first saw a 2 here. So R is now here, so we just swap this 2. So this becomes 2 and this becomes 1. Okay, so now our next element is a 2. So we did, if it is a 2, then we swap it with this one and R move to next. And do not increment by. Yeah, so our R is now here. That's weird. Our R is less than our index now. So that means we've gone too far and we should stop. Right? So if R is less than index, that means we should do nothing and just break the loop. Yeah, okay, let's try to write the code. equals 0 and left equals 0. Right equals n minus 1, so plus nums minus 1, while I less than n and left is less than r. If nums I is 0, swap with swap with nums L. That means nums L is now swap with nums L, so nums L and nums I swap. And L has to increment by 1, and I also increment by 1. If nums I equals 1, we do nothing but increment I. Else else if so else, that means nums I equals no, it doesn't mean that. So it's it. Yeah, else swap with nums R. Okay, nums R, nums I equals nums I, nums R. And decrement R and do not increment I. Okay. So if R is smaller than I, break. Okay, now let's run another example to check if our code is right. Let's try another one. Two, 1, 0, 0, 2, 1, 0, 2. Oh, that might be too long. And just end it here. Okay, so I equals 0 and L equals 0, right equals the last number, the last index. Well, I is less than n. Okay, n. I have not specified n. Oh, I is less than actually just less than right. So we keep moving right. If I has passed the right, then we don't really need to check anything. Then we can just remove this code. I is less or equal, maybe equal than R. R is the last number, so I should be able to continue until the last number, so just give it equal. Okay. If nums I equals 0, no, nums I is right now a 2. So go to the else. And we swap R and I. R and I swapped. Nothing happened. And R minus 1. So R becomes here. Okay. And next I is 1. 1, we do nothing, just increment I. Oh, by the way, so I is still here because we did not update I when we run this else, right? So we still have this 2 here. It is still 2. So when we run this loop again, and we go here, we come here again, and this time we swap the 2 with 0. So now, and update the R. So R is here, and this becomes a 2, and this becomes a 0. And we still have not updated the I. So we have to run this loop again. So now the nums I is 0. Okay, so it swap with the L. The L is still here. So L plus 1, so L comes here, and I move to the next. And right. So we go to the beginning of the loop. So now if nums I equals 1 now, we do nothing, we just increment the I. Okay, and now nums I equals 0, and nums I swap with I swap with the L index. So this is 0, and this becomes 1. And we have to move L to the next. So L is here, and I to the next. Now I is a 2. By the way, so our condition was I less than or equals R. So I is now So when we on this one, I is here, and R is here, so it is equal. And when we move I to the next, it is bigger than R, so we should not go there. So we are out of the loop. And it seems like, yeah, we already have this array sorted. So now we just need to return the array. Okay. So what is the time complexity of this problem, this approach? And we have run one loop from start to end, so it is O of n, and the space complexity is O of 1 because we do it in place. Okay, that's it. Thank you for watching. Bye bye.